Hi everyone. The logistic regression is one of the predictive analysis algorithm which is using to classify the given data set based on probability theory, which is measuring the relationship between independent variables, which is also called features, and the discrete dependent variable by estimating the probability values by using the logistic function also called sigmoid function here, which is assigning the values to discrete set of classes, and also the logistic regression is called as binomial logistic regression. Here labels are denoted by using the discrete values in the sense different names, banana here, banana. So there is no relationship between the that is like range, but like 0.2 0.5 like this, there is no continuous value, so discrete values will be there for each and every sample. Here example for the logistic regression, we can say the mail is classified as a spam or not spam, online money transactions are called as fraud or not fraud, and tumor is classified as malignant tumor or benign tumor. So here the data set is classified into two categories, A and B. That means one is orange and another one is banana. Okay, so the decision boundary is classifying the given entire data set into two classes here. The logistic regression is transforming its output using the logistic function by calculating the probability value. We using the function 1 divided by 1 plus e power minus z. The logistic regression value always between the 0 to 1. That means the calculated output h of x or y dash belongs to either 0 or 1. It can be represented as the hypothesis value we have calculated between the 0 to 1. And the logistic regression can be applied to binary classification and also multi-class classification. Binary classification in the sense our entire data set will have only two classes. For example, the banana class and orange class, all the data points will be belongs to only two classes. So this is the class A, and these data points are calculated as class B. Only two classes available for entire data set. If multi-class classification in the sense, then the data set will have more than two classes like apple, orange, and banana. So this is class 3, class 2, this is class 1. So it can be represented like this. These data points are belonging to one class, and these data points are belonging to one class. The red color data points belonging to uh, third class. So if there is data set have more than two classes, then that kind of data set is called multi-class data set. So logistic regression can be applied to multi-class classification also. Here the assumption will be taken as a dependent variable must be categorical in nature for the logistic regression data set. That means here the label will have only the categorical value, that means text data, it will not have the numerical data. The independent variable should not have multicollinearity. That means the independent variable here x1, x2, x3 should be independent of each other. There should not be a correlation between these features. So here we can use the sigmoid function to estimate the probability value for the given features by using the function sigmoid of g equal to probability value equal to 1 by 1 plus e power minus g, right? So here it can be written as 1 by 1 plus e power minus z, it, right? So it can be expanded like e power z divided by e power z plus 1. So this function is used to calculate the value either 0 or 1. This term can be expanded into this format like 1 over 1 plus 1 by e power z. So this term can be expanded like this. Then here we will get 1 over 1, that is this e power z can be taken as here e power g plus 1 divided by e power g. Then it can be bring into this, will go to the numerator e power g divided by e power g plus 1. So this also can be represented to a sigmoid function. Here what is the g? So g is the summation of the parameter and multiplied with feature values. So that means theta 0 x0 plus theta 1 x1 plus theta 2 x2 etc theta n xn. Here xi is the independent variable that is given like these features, right? And its corresponding parameter values it will be given in the problem statement etc theta n. Okay, so here whenever our predicted value greater than or equal to 0.5, suppose I am calculating the y dash by using the uh, sigmoid function, I got 0.7. So the 0.7 is calculated value greater than 0.5, then it will be predicted as a 1. So for that x value, here we can assign the value in the form of value 1 in the predicted axis. Now if my predicted value is 0.2 which is less than 0.5, then we have to mention in the value y as 0. So like that, wherever we are getting the values between the this 0 to 1, we have to make it into either 0 or 1. Suppose I am getting the predicted value y dash equal to 1 lakh. So this 1 lakh is greater than 0.5, right? So it has to be converted into the 1. Suppose I am getting the minus 1000. This is less than 0.5. So we have to make it as a 0. So that value will be denoted in the 0 of y value. So whichever value we are getting, it will be transforming into the 0 class or class 1. So when you are joining this value, this will look like S curve, sigmoid curve. So this is the sigmoid curve for the logistic regression function. Here the 0.5 is the default threshold value for the sigmoid function. If you want to change the threshold value, you can change it by manually, but the default threshold value always for the sigmoid function is 0.5. Thanks for watching.